Hello everyone, this is me Saidur Rahman. This will be my presentation for the paper Deep Learning-based Predictive Caching in the Edge of a Network. This research paper was accepted and is being presented for the conference, International Conference on Information Networking 2020. So let's get started. I am Saidur Rahman, working as a lecturer at the Department of Computer Science and Engineering at BRAC University, and these are the other two authors of this research paper. These are the topics that I'll be covering in my presentation, and so let's have a quick look at them. I'll be talking about, I'll go with the introduction, then we will cover some theoretical background, then the methodology that we have followed, and then we'll discuss the results, and finally we will look at the future work. So basically, in edge networking, in edge computing, we have edge devices between the user and the cloud server, and the edge devices have a finite storage. For this reason, we need to make smart decisions to cache the web content in the edge devices. We cannot store everything in the edge device because unlike the cloud servers, they have very limited storage. So in this paper, our main motive is that we will develop a recurrent neural network model which will be using long short-term memory LSTM cells, and this model will be trained using the MovieLens 20 million dataset. This dataset contains 20 million entries of movies. So after we have trained the model, then we propose a algorithm which helps to make smart caching decisions in case the edge device is filled, or in case of like a new more popular movie. So now I will be covering the theoretical background necessary for the research paper. So what is edge computing? Basically, we need to understand three things to understand what edge computing is. Edge computing consists of a cloud server, a network edge, and the user end devices. In traditional systems, the user end devices stream data directly from the cloud server. However, in edge computing, we have edge devices which act as an interlink between the cloud server and the end device. Now, the edge devices are of fewer computational capacity as well as fewer storage compared to the cloud server. For this reason, we need to be very careful about our use of the edge devices, because we cannot perform every action on the edge device, and the edge device has to perform only the activities that are of crucial importance and which will eventually help the user to have a seamless experience when browsing content. As we can see from the figure, that the user end devices are connected to the network edge, and the network edge is in turn connected to the cloud server. So usually all the data is present in the cloud server, and out of all this data, only some selective data is copied in the edge network or available in the edge network. The content that we choose to store in the network edge are basically chosen on whether user will demand that content, how more the users will demand that content. So when this some content are cached in the network edge, the end result is that users have a seamless a very smooth experience in browsing the content. Now we come to the caching model. Basically, in the previous slide, I have talked about the importance of a network edge and how the mechanism of edge computing is basically designed. So in this part, I will be mainly talking about how the caching part is done. So as you can see from the given figure, that there are two parts: the cloud data center and the network edge, and the management module acts as an intermediary between these two parts. So the cloud data center is the part where we have the we have the computers, or we have the servers with more computational capacity, more storage, and basically every data is present in a cloud data center. However, but the network edge has some very few finite resources, basically the resources which are of utmost importance. So if you can see from the given figure that, as I have already mentioned here, that basically the data is being used in the cloud data center first. It is pre-processed, and then it is being used to build the model and to enhance the model, I mean the predictive model that will be used for the prediction of the popularity. Once we have trained the model, we will use the results of the prediction to make decisions about the caching. Like, let's say we predict that a certain movie will be very popular in the future, so that means that movie this movie qualifies to be cached in the network edge, because users will eventually demand this movie more. So now we will be talking about how we will be building the predictive model that will eventually predict the popularity of a content, and in this case the movies. We will be basically building a recurrent neural network which will be using long short-term memory LSTM cells. The figure on the left shows the internal mechanism of an LSTM block. We can see that it contains some gates, namely the input gate, the forget gate, and the output gate. Basically, some functions such as sigmoid functions, tanh functions are performed on the input and output of the various gates or valves, and depending on what operation is being performed and at which gate, we can determine which information we want to store and which information we do not want to store. So eventually we will be getting only the information that is necessary and not the ones which are not. It is explained in greater detail in our research paper, which will be published and will be available to view. On the right hand side, we can see how we have developed how we have designed the entire architecture of the recurrent neural network model. As you can see, first there is an input layer, then we have multiple layers of LSTM cells, then we use a dropout layer, after that we have a dense layer, and finally we get the output layer. So that is how we designed the architecture of the RNN LSTM model. Now comes the methodology part of the presentation. So here we have broken down the entire methodology as a series of steps. The first step being the data pre-processing, the second being feature selection, the third is exploratory data analysis, the fourth is prediction model, and the fifth is the caching decision algorithm. Data pre-processing and feature selection are explained in this slide, and steps 3, 4, and 5 will be explained in the slides that will follow. So exploratory data analysis. This is basically done to gain hidden insights from the data and to gain a more holistic view of the entire data. In our research paper, the EDA consists of two analyses: the annual hit rate analysis and the genre-wise movie analysis. So first, let's talk about annual movie hit and rate analysis. So basically for this analysis we have used a box plot, as you can see in the leftmost figure. Here we can see that the median number of movies that are demanded each year does not vary very significantly. Some years very less movie demand is seen, and in some years the demand is significantly higher. So there is quite a variation in the years and with the demand in the movies. Then comes the genre-wise movie analysis. Here we can see that the most popular movies are comedy and drama movies, and the least demanded ones are IMAX and film noir genre. So this helps us to gain an insight as to how the underlying property of a movie might influence its popularity. Next, we discuss the prediction model. So to build the prediction model, these are the steps that we have followed. So let me just walk you through the entire process. First, as I have already mentioned, we have used the MovieLens 20 million dataset to build the model. In order to make the make the data more usable, we had to do data pre-processing, and we also had to do feature generation. Next, we did exploratory data analysis, which I've already mentioned in the previous slides. And after that, we get a prediction. After that, we move on to the prediction process. Here, first we do a train test split of data. Then we do data scaling using the min-max scaler. And finally, we hyper-tune the parameters for the results with the highest accuracy. Finally, we evaluate between different models and different models using the criterion of validation loss, validation mean squared error, and validation root mean squared error. Now you can see the specifications of our recurrent neural network model and how we have designed the model, and what are the various values of each of the features of the model that we have used. For example, we have used 50 LSTM cells. The dropout layer value was 0.075. We used a batch size of 500, and we trained the model for 1100 epochs. The optimizer that was used for this for creating this model was the NADM optimizer, and we used the Keras library to build this model. So basically, this is the caching decision algorithm that we propose. This decision or this algorithm will be used at the edge device when using the prediction decision from the RNN LSTM model. Basically, the RNN LSTM model will give a prediction to the edge device. The edge device will use this algorithm of cache decision process to make corrective actions which are explained in this algorithm. Now let's discuss the results of our paper. So the table shown here shows that for the three models that we have trained on different movies, namely movie 296, movie 6377, and movie 49272. So from the values from the table, we will come to the conclusion that the model 2 will be the most successful in terms of the accuracy of prediction, and therefore model 2 should be the model that will be eventually selected for prediction in the cloud server, and whose prediction decision will be used at the network edge. This figure shows that when we give a new movie which was unseen to the model, and this movie was Ocean's 11 model with movie ID 4963. So the graph shows that model 2 has been quite successful in forecasting the future popularity of this movie, and it could very well show and demonstrate that how this movie's popularity will change over time. So this will be greatly beneficial for the caching decision to be taken in the edge device. So now we come to the end of our presentation, and so basically for extending our work, we want to use the recurrent neural network model with gated recurrent units known as GRUs, and we also want to try out the convolutional recurrent neural network model to build the model that is being trained at the cloud server, and that is being used for gaining prediction of the popularity. So we are very excited for future work, and these are the basically references of the various papers. So thank you very much, and please feel free to reach out if you have any questions.